Hello everyone, I hope you're doing good. So I'm posting 2 videos in a row today, so I hope you enjoy it. We are looking at the same paper as the previous video, February-March 2025, paper 1-2. This time is question 29. So this is a diffraction grating question, but a different one, actually one that I've never seen before, but it's actually doable if you understand the question, because this question is all about understanding the formula, and if you do, this question is a piece of cake. So let's get started. Light of wavelength 567 nanometers. So this is something to be aware of. It's in nanometers, so you gotta convert it later. Do not forget to convert it. It's incident on a diffraction grating. The grating has 400 lines per millimeter. This also you need to convert. A number of diffraction maxima observed on the far side of the grating. Okay, what is the angle between the second order maximum and the third order maximum? So usually diffraction grating, they ask you to either find the angle or which order of maxima is it, but they rarely, or maybe because I've never seen this question before, so I'm not sure if it appeared in the older years, but they don't really ask between 2 order angles, but it is definitely doable. So let's get started. So we know that diffraction grating has this very famous formula that follows n lambda equals to d sine theta. So let's actually understand what each of these quantity mean in the formula first. So n is actually the number, I would say more accurately is the order of maxima, and this lambda is the wavelength. Okay, I think I should write this better. Wavelength. And d is the distance. Wait a minute. Is the distance between slits, or in other words, some people may call it as grating spacings. And theta here is the angle of diffraction from center to the end order. Oopsie. Okay, wait, let me zoom it back to the nth order. So to put it simply, if I were to draw, this is the 0 order, right? The 0 order. So let's say we are looking at the second order. So this would be your theta from the center, the central order, to the second order. Okay. Now, we know how the formula works precisely. Let's start solving the question. Now they want us to find the angle between second order maximum and the third order. So that means this is 0 order, this is second order, this is, let me move a bit, this is third order. So they want us to find this. But the theta in the equation gives us the angle from center to its maximum order, to its nth order, basically, whether you want it second order or third order. So if you want second order, you sub in 2 here. You want third order, you sub in 3 in your end there. It depends. So what we can do now is, first we can find the angle of third order, then find the angle of second order, which is from here to here, then minus it, you will get your x. So if I were to label the angle for the third order is y and second order is z, then to get your x, or to get what the question wants, you just take y minus z and you will get your x. Easy as that. So now let's substitute our values in the equation. Okay, so let's start by finding second order first, okay? So second order like the formula, n lambda equals to d sine theta. Our n is 2. Lambda is in nanometer, so please be aware of that. It's 576. Oh, not 576, sorry, 567 times 10 to the power of negative 9, because we're changing nanometer to meters, equals to d. Yep, and here, this is where you need to be very, very careful. In the question here, they gave you 400 lines per millimeter. This is actually the number of slits per unit length. Or in other words, they denote it as n. And to find your d, your distance between slit, is actually 1 over n. And here you need to do another extra step, which is convert it to meter, because this is in millimeters. And to convert it to meter, you times 10 to the power of negative 3. So 1 divided by 400. Yeah. Wait. 400. Then times the whole thing by negative 3 to convert it to meter. Okay, let me just put this to the side here a bit. Oops. I'll only bring the above one, so I don't have enough space. Okay, then sine theta, which is what you're going to find. So you do your math, take out your calculator. You don't have to do step by step here, because this is paper 1 and they're not going to see your working in paper 1. So as long as you know what you're doing and you get your answer, you are good to go. Okay, wait, let me get calculate. Okay, and I will get 26.97489. So this is not your final answer. Like I've always said, please write more than 4 decimal places or more than 3 decimal places. It's better. And remember to set your calculator in decimals and not radian. You know, you do a lot of math, sometimes you may put it in radian and you get a very different answer. So please don't do that. Check. Okay. Now third order, same step, just the only thing is going to change is your n value. I know in exam you may do your calculation fast, but make sure you are aware of what you're putting in your calculator so that you don't get it wrong. Okay. And I will get 42.87491 degrees. So now, to find what the question wants, which is the angle between second order maximum and third order maximum, you've got to minus this both. Okay, so let me label it in the diagram and perhaps we can see it clearly. So the question wants us to find this x, the one I labeled in red. We know our second order angle is, okay, so this is not drawn to scale, so I'm just roughly drawing it, okay. So this is our second order angle, and our third order angle is this, which gives us 42.87491 degrees. And to find this angle in red here, by basic maths, what you do, you take 42 minus by 26. So that is what you're going to do. So to get this, take 42.87491 degrees minus 26.97 degrees. And you should get 15.9 degrees. And your answer is C. Yes, your answer is C. So, what is a takeaway from this question? Is you should know what is the theta representing in the equation. What does the theta here represent in the equation for you to solve this? Then second one, be careful of your D when you're finding your D. Remember, this is number of slits per unit length. So to find your D, you need to take 1 divided by n. Then you find your third order angle and second order angle, minus them to get the angle between the second order maximum and the third order maximum. And there you go, you've gotten your answer. So this is actually an interesting question, because as far as I'm concerned, I've never come across this before, but it's definitely doable if you understand how the formula works. So make sure to understand your formula and not just memorize it. Okay, and that's all for today's video. I hope you get an idea on how to solve this question and understand better about diffraction grating. And I'll see you in the next one. Please take care of yourself, stay hydrated, and bye bye. See you.